Okay, working the homework for 7.8 phase shift. All right, so we want to find the amplitude period phase shift of this function. So first of all, amplitude is 6. All right, period. So we take 2 pi and divide it by the number in front here, which is going to be 2 pi over 3. 2 pi over 3. Okay, and then they want to know the phase shift. So for phase shift, we have to figure out what phi is. So phi here for us, remember there's a minus here, so phi here would be, where's my pen? Phi here would be pi, okay? And so the phase shift is going to be phi over omega. Omega here is 3. So we got pi over 3. Okay, so omega is the number in front of x there. So our phase shift should be pi. Will it do pi? Yeah, cool. If I type pi, it'll do that, pi of 3. Okay. Now we want to graph this thing. So let me see here. I think we can do this without going through the long process that we do in class. So we want a sine function, right? Boom. Okay. Want the amplitude of this to be 6. Want the period to be 2 pi over 3. And we want the phase shift to be pi over 3. Let's just check that. Yeah, that'll be not bad. Okay, what is the amplitude of this? 5, that's the number in front. Period is 2 pi over the omega, which is 2 pi over 2, which is just pi. And then the phase shift is going to be, hold on, let me see here. Pen. Okay, so phi here is going to be negative pi over 2. And then omega is 2. So the phase shift will be negative pi over 2 over 2, which is really negative pi over 4. So it's going to be a shift, but it's going to go to the left by pi over 4. So let's see how they want this. I'm going to try and put negative pi over 4 and see what happens. Yeah, okay, so it wants it exactly written with the correct sign. So, all right, so now we just go, it's a cosine function, so it looks like this. And that has an amplitude of 5. Period is pi. And the phase shift this time is negative pi over 4. Let's see if it'll let me do this. Negative pi over 4. Okay, let's try that. Uh-oh. What did I do here? Oh, that was vertical shift. Oops, sorry, I accidentally did vertical shift instead of phase shift. That should do it. Okay, my fault. Okay, so now amplitude is 4, but we're going to have a reflection over the x-axis. Don't forget that. Okay, we have period, which is 2 pi over 6, which is going to be pi over 3 when you reduce the fraction. And now this part, we're going to take our phi, which is negative pi over 2. Be careful because there's a plus there, right? Plus there. So in the formula, it has to be minus. So you go minus negative pi over 2. And then over this 6, and that's going to be negative pi over 12. So negative pi over 12. Now let me try and graph this thing. It is a sine function. Boom. Amplitude negative 4, or 4 I should say. Period is pi over 3. Phase shift was negative pi over 12. And we had a reflection over the x-axis. That's it. Okay, write the equation of the sine function has the following characteristics. So it has a period of 3. Okay, I'm sorry, period, amplitude of 3. Okay, so this is a little tricky. The period needs to be 7 pi. So remember, your period is going to be, I'm going to call it P. Your period is always going to be 2 pi over omega. And omega is the number in front of x. So we're told that the period is 7 pi. And so that has to be 2 pi over omega. So I'm going to multiply both sides by omega to get it out of the denominator. And that'll get rid of that. And now I have 7 pi times omega equals 2 pi. And then I divide both sides by 7 pi. Pi's cancel and you just get 2 over 7. So the number in front here should be 2 over 7. And then your phase shift is a half. And since there's a minus sign in the formula, I'm going to just go 1/2 there like that. That should do it. What? Period. Hold on, I'm going to just check it again because I want to see what the heck is going on here. Oh, yeah, I messed up. I apologize. Yes. Okay. Sorry. Phase shift. Okay. So remember, I think it's too late. What time is it? It's almost midnight, 11:20. It's been a long week. My computer has been giving me all kinds of problems. Just making excuses. Okay. So phase shift is phi over omega. I apologize. They're telling us that the phase shift is a half, and we're trying to figure out what phi is. And then omega, we already know, is 2 over 7. So what I'm going to do is I'm going to do the reciprocal over here. So I'm going to basically get rid of that and multiply by 7 over 2, which is the same. Okay, so this is 7 over 2 phi. And now I will multiply both sides by 2 over 7 to get phi by itself. Boom, boom. And then the 2's cancel, 7 cancels. So you get phi here. Here you get 1 over 7 is all that's left. And so that should have been a 1/7, my fault. All right, let's do a similar question. Okay, amplitude 2. Okay, period is 2 pi. Okay, so that's a little easier because if the period is 2 pi, I'll clear this out. If the period is always 2 pi over omega, and they're telling us that the period is just 2 pi, I think it's obvious that omega would have to be 1 here, because 2 pi over 1 would give you 2 pi. So I know that that has to be a 1 there. And then to figure out the phase shift will be phi over omega. But the phase shift they're telling us is 1/9. That must be phi over omega. But omega is 1. So that means that phi has to just be 1/9. Okay. Okay, this one will be a little bit like that last one. So what am I doing? What number am I on? 5? Okay, amplitude is 9. Period is 6 pi. So I know my period must be 2 pi over omega, but the period they're saying is 6 pi. That must be 2 pi over omega. Multiply both sides by omega, and then divide both sides by 6 pi. Pi's cancel. 2 over 6 is 1/3. So omega must be 1/3. Let me figure out the phase shift. The phase shift should be phi over omega. The phase shift is -1/4. And omega, we know, is 1/3. So if I reciprocate that 1/3 up, I get 3 phi. And then divide both sides by 3, I get -1/12 equals phi. And so our phi is -1/12. So this would have to be, notice there's, oh, I forgot to put this in here. It's 1/3. That's our omega. And then because there's a plus here in the formula, this is going to need to be 1/12, because that's really like -1/12. And our phase shift is supposed to be -1/12, so we put +1/12 there. All right, that should do it. All right, Next one, let's see what we got here. Find the amplitude if one exists, period, phase shift. Okay, so tangent functions don't have amplitudes. So we move on. Okay, so the period, the way we get the period here is we say, remember with sine, we were always doing 2 pi over omega, the number in front of x. Here, what we do, because it's a tangent function, is we do pi over that omega. So pi over 5 would be our period. So that number in front, 5, we divide pi by that instead of 2 pi. And so that gives us this here. Come on, pi over 5. All right, and then the phase shift is exactly the same as we did before. So what we're going to do is we're going to take phase shift will be equal to phi over omega. So our phase shift will be phi, which is pi, not negative pi, but pi, and then over or omega, which is 5. So we should get pi over 5 here. All right, next one, choose the correct graph. All right, so the period is pi over 5. So let me see here. This is pi over 10, pi over 2. Let me see. Here we go. Here's pi over 5. We're looking for the period, right? So it goes from 0 to pi over 5. Then another period would go 2 pi over 5. So this looks like it here. None of these other ones. Oh, wait, this one has a pi over 5. Oops. Okay, but it's a tangent. Yeah, it's a tangent function. So it has to look like this, not like this. That's more of a cotangent. So looking like that. Let's go with that. Nah, I knew that wasn't going to be it. Okay, hold on. This is the period. We need a phase shift of pi over 5. All right. I don't think we're going to get away without having to do this one by hand. Okay, that's all right. So the way we graph tangents, we take 5x minus pi, set it equal to do a tangent, we set it equal to negative pi over 2, 5x minus pi, and set that equal to pi over 2. All right, here we go. Add pi to both sides. You get 5x equals, that's just pi over 2 on the right-hand side. And divide by 5, you get pi over 10. Then over here, you add pi to both sides. You should get 3 pi over 2. And divide both sides by 10. I mean, by 5, and you get 3 pi over 10. All right, so we got to figure out where we would have vertical asymptotes of pi over 10 and 3 pi over 10. That looks like here. Pi over 10, 3 pi over 10. Pi over 10, 3 pi over 10. So it's either this one or this one. However, it's got to be a tangent function. So this looks like cotangent. So it's got to be this one. Okay, so earlier when I said pi over 5, that was just the period. That wasn't, because we had a phase shift, it moved it over, which is why it wasn't these two. So where was I? This one, right? This one looks like a tangent, and it starts at pi over 10, ends here. Yeah, there we go. All right, what is the amplitude of this? Well, this is a cosecant function. Cosecants don't have amplitudes because they have those little parabolas. So it doesn't have amplitude. All right, what's the period? So the period is, because it's a cosecant function, it's a reciprocal of sine. I just do 2 pi divided by omega. So that's 2 pi over 3. Okay, and phase shift. So phase shift, we're going to take this, and because it's a minus, we're going to just take pi over 4 and divide it by 3. That would give you pi over 12. Okay, and we want to graph. Okay, pi over 12. Phase shift is pi over 12. So it's, let's see, cosecant. So it's a sine function. I'm trying to think if there's an easy way to do this without. Yeah, so it's got to be a sine function. Let me draw on this. Sine functions go like this. And then anywhere we have x-intercepts, We have our verticals. And so we should have a U going like that, and then like that. And then it's been phase shifted by pi over 12, and it's to the right because that was a minus sign. So it's like a U, but the whole thing's been moved to the right, pi over 12. So see the pi over 12 here, but see the U starts at the bottom. It can't be this one. This is pi over 12 and the U starts at the top. It looks like that. Can't be that. Can't be this one because it's been phase shifted to the left instead of to the right. So it's got to be that one. Last one. Okay, it's a cotangent function, which normally looks like this, but it's flipped over. So now we know it looks like that. And so to do cotangent, don't think I'm going to be able to avoid this. I'm going to have to take the inside and set it equal to 0, and the inside and set it equal to pi. That's what we do for cotangent. Okay, if we move that over to the other side, you get 2x equals negative pi over 2, and then divide, you get negative pi over 4. And then here, when you take the pi over 2 and subtract it on the other side, you get pi over 2, and then x is pi over 4. Divide by 2 again. So negative pi over 4, positive pi over 4. Those are our verticals. Here at 0, we have our x-intercept. And again, because it was a cotangent that's been flipped, it's going to look more like a tangent. And so which of these will it be? See, we're looking at negative pi over 4, pi over 4. Right here, negative pi over 4, pi over 4 looks like a tangent kind of because it's cotangent flipped over. This looks like it's it. There we go. Oh, good. That's all I wanted. Great. Wonderful. All right. So this one, it's a secant. It's -2 in front. So I'm going to need to go ahead. I'm just going to take my time. I'm going to graph this because secant is a reciprocal of cosine. Okay. I'm going to set the inside of that equal to 0. And then I'm going to set the inside of that equal to 2 pi. Okay, when I set it to 0, I get 2 pi x equals negative pi. And then divide both sides by 2 pi, get x equals negative 1/2. Take the pi to the other side. I get pi here. And divide both sides by 2 pi, I get 1/2 there. So it's going to look like this. Negative 1/2, 1/2. Okay, halfway is 0. Halfway here is negative 1/4. Halfway there is 1/4. And this is going to look like a cosine that has an amplitude of 2. But it's a cosine function that's been flipped over. So remember, cosines have x-intercepts at the quarter mark and 3/4 mark. It's supposed to go like this, but it's been flipped over. So it's actually going to go like this. And anywhere we have x-intercepts, we have a vertical asymptote. And then our cosecant function, or secant function, sorry, is actually just this parabola here, like that. And then a parabola-looking thing that looks like that. So let's see, cannot be this, right? Can't be that. Can't be this because the y-axis here cuts through. Here, our y-axis cuts through, but it goes up. Can't be this because our y-axis doesn't cut through any of the little parabola things. Here, let's see, 1/4, negative 1/4. Parabola thing looks like it goes right through the middle. That looks like it right there. Am I done? Am I done? Yeah, I'm done. Oh, awesome. Okay, done. Happy about that.